A very good morning to everyone present today. Ladies and gentlemen, myself, Divya Kumaran, as a leader of the newly hired employee team by the Domingo company, will be introducing the recommendation of solution for the problem that was addressed by the company, which is rising of utility bill every month. So first of all, I will start by introducing my team members. Myself, the leader, Divya Kumaran, followed by my secretary, Nurul Afifa binti Ishaq, and my treasurer Tang Chi-yong, and the two other members who's Nur Fatin Liana binti Ishaq and Nur Elina binti Saifulizan. As we look into the problem, we realize every department and throughout the company fluorescent light was used. So me and my team put our head together in 3 meetings to come with the best solution which can help the company in energy consumption and reducing the utility bill every month. After 3 meetings, at last me and the team decided to change all the fluorescent lamp to LED type. Me and my team had to differentiate 2 best brand of LED lamp which will help in the energy consumption. Of course, we can't simply recommend any LED lamp. We have to choose the best of the best. So during our analysis and data collection, we realized there was 2 best brands. Later on, my team members will discuss the spec of the 2 LED lamps. At last, the best of the best LED was chosen because it has the best energy consumption. My team member will discuss on the specification and the conclusion and the reasons of why we chose the specific LED.
The first criteria to be evaluated is the nominal voltage. Nominal voltage is measured in watts, where the value for the ability of LED to keep on turning on without causing any overheating. With the environment at the factory always running 24/7, a low nominal voltage from LED can contribute to reduce electricity bills. Choosing a low nominal voltage means that LED installed have a longer lifespan since they only need a small amount of power to function. Other than that, lower power consumption can help to reduce the heat in a room. Sylvania consumes 150 watt per hour and LED vents nominal voltage is 155 watt per hour. By looking at the value of nominal voltage of both brands, the higher the watts means the brighter the LEDs. However, brighter LED with high nominal voltage will cause the company to pay a greater amount of electricity bill. The other important criteria are beam angle for the LED, which is to measure how much light can be distributed or emitted. The beam spread of the light can be categorized into 3: narrow, medium, and wide. The beam angle for Sylvania is 60 degree and LED vent has 110 degree. The wider the beam angle, the further the space between the light, which can cut costs on purchasing the LED. Next criteria is average life of the LED. The average life or lifespan of the LED is usually printed at the back of the packaging, with an average of about 5, 10, or 20 years. However, the correct way to know the lifespan of the lights installed depends on how many hours it's been turned on. The average life of Sylvania is 23,000 hours. The average life of LED vents is 35,000 hours. Thus, the LED vents has a better average life and save the cost of replacing it after about 4 years that compared to Sylvania, which can only last for 2.6 years.
Criteria to be evaluated in choosing the best LED to be installed to our company is luminous efficiency. Luminous efficiency is a measure how good a light source produces a visible light. The flow of charge through the filament hits the light bulb and causes it to glow. The power for the total radiation from the source called luminous efficiency of radiation, which is dimensionless. In this case, it may be expressed as percentage and called luminous efficiency. A common choice for the monochrome light at a wavelength of 555 nanometer, the maximum possible efficiency equal to 683 LMW-1 correspond to an efficiency of 100%. The light bulb converts electrical energy to heat energy and light energy. The ratio of luminous flux to power measured in lumens per watt. Luminous efficiency for Sylvania and LED vans has been done. The luminous efficiency for Sylvania is 130 and for LED vans is 140. The higher the value of luminous efficiency, the less power consumed and more money will be saved. We can see the value of luminous efficiency for LED vans is higher than Sylvania. One of important criteria to be evaluated is electric current, which includes the inrush current and drive current. An electric current is a stream of charged particles such as electrons or ions moving through an electrical conductor or space. It is measured as the net rate of flow of electric charge through a surface or into a controlled volume. The unit for electric current is ampere. There are two types of currents that have been figured out. First, inrush current. The inrush current is the maximal instantaneous input current which flows into the ECG, electronic control gear, by an electrical device when first turned on. The initial means power up and the currents flow only a few seconds to charge the capacitor on the input side. The currents will reduce to a lower steady state currents once the input capacitor charged. Second is drive current or nominal current. Drive current is the electrical current flow through the light to operate it in conventional time. The inrush current and drive current for Sylvania and LED vans has been compared. The inrush current for Sylvania is 60 and for LED vans is 49. For drive current, Sylvania is more than LED vans, which is 3210. For LED vans is 710. Lower current value consumption, more the electric bills can save.
For conclusion, after all the considerations, our team has decided to convert an outdated fluorescent lamp to light-emitting diode. We have selected and compared two high-quality LED lamps from different brands, which are Sylvania and LED vans. First, the nominal voltage for Sylvania LED consumes 150 watt per hour and LED vans LED is 155 watt per hour. A low nominal voltage from LED can reduce electricity bills. The lower nominal voltage between both of the lights is Sylvania LED. For luminous efficiency, Sylvania has a luminous efficiency of 130 lumens per watt, while LED van has a luminous efficiency of 140 lumens per watt. The greater the luminous efficiency value, the less energy is consumed and the more money is saved. So that from this case, the greater luminous efficiency is LED vans. Third, Sylvania has a 60 beam angle and a glare control of 25.9, while LED vans has beam angle of 110 and a glare control of 29. The larger the LED's beam angle, the more areas the light can cover. As a result, the company can buy less LEDs to cover a wide area around it. The LED vans was chosen. For the electric current criteria, the inrush current of the Sylvania is 60 amperes, while the inrush current of the LED vans is less than that the Sylvania, which is 49 amperes. When the electric currents value for both brands are compared, the LED vans has a lower current value consumption and can help company in saving energy bills. 5. After being calculated, the average lifespan for Sylvania is 2.6 years, while LED vans is 3.9 years. As a result, LED vans has a longer average lifespan and save money by only having to replace after about 4 years.
Based on the comparison and discussion made before, the LED1 HB115W6500K IP65 LED is strongly recommended for its overall performance and quality. This is because the beam angle of the LED1's LED is about 2 times wider than the Sylvania LED. For example, if a room requires 4 units of Sylvania LED to light up the whole room, but if using the LED1's LED, it only requires 2 units to light up the whole room. Besides that, LED1's LED is brighter than Sylvania LED. From the comparison, the luminous efficiency of Sylvania LED is 130 lumen per watt, while the LED1's LED is 140 lumen per watt, which means by supplying 1 watt of power to the LED1's LED, it will produce 140 lumen of light. Furthermore, the average lifespan of lead one's LED is longer than silver LED, where the lead one's LED can last about 1.3 years longer than the silver LED. In addition, the lead one's LED only lead a very low current that compared to silver LED. When the current used is too high, it will direct affect the heat produced by the LED, which means that the surrounding temperature also will be affected. Finally, by choosing the lead one's LED, it will help the company to obtain greater benefit in saving the monthly expenses cost, as it has more advantages than silver LED.